Hello everyone, a good day to all. So thanks for joining this webinar session. So the webinar is all about high performance data acquisition with Azure Functions. And the webinar will be presented by Rickard Conway. So in today's enterprise scenarios, more and more Azure functions are being built using API clients with solid data acquisition strategies. So these are used in data and reporting patterns like Lakehouse and Microsoft Modern Cloud Data Warehouse patterns as well. So in this webinar, Richard Conway will discuss how to build and integrate APIs into your data practice and the things you will need to think about and understand, such as Azure functions and other things as well. And about the speaker, Richard Conway is a Microsoft Regional Director and an Azure MVP for a decade now. So as a founder of the UK Azure Group's community, he is a strong community advocate and an open source contributor as always. So his interests are around being big data platforms and cloud. So the session is all yours, Richard. You can start.
Wonderful, wonderful. And thank you for the grandiose introduction. So today I'm going to be talking about high performance data acquisition with Azure Functions. It's an incredibly interesting topic, and I think that maybe through these webinars, because there's a very strong focus on the integration aspects of Azure, integration and data have become very close partners in the cloud, and so you can't really talk about one without the other. So what I'm going to do is I'm going to present some strategies that might help you think about how you can make your data platforms perform much better. I'm going to introduce Azure Functions. Some of you may have used them before, but I'm going to go from very basic to very advanced quite quickly to explain some patterns. And I'm going to explain to you how Microsoft think about data as well and where this fits in. So a little bit about me. I am a Microsoft Regional Director and an Azure MVP, which I've been for a decade now. If you use Twitter and you want to follow me, my handle is Azure Coder, and I tend to blog about everything that I talk about as well. I'm the CEO of ElastiCloud, and we're very specialized as a company around data. Trusted Microsoft partner in the UK. As in the introduction, I founded a lot of groups and communities, so you can see some of them here. The UK Azure Users Group, IoT and Data Science Innovators, the Cloud Infrastructure User Group, and Data Science London. You can find all of these on Meetup. And one of the things that we do is we do our meetings in the Microsoft Reactor in London. And so even if you're not based in London, you can pick up the stream because it's live streamed out to from the Reactor building onto YouTube. So if you're interested in some of the things that I talk about, then feel free to join the Meetup group, UK Azure User Group, and you can pick up the live stream. And then similarly, I'm a very strong open source contributor to several Apache projects, mainly Spark and Parquet, and these are very important to the data ecosystem. So if you have a healthy interest in these things, definitely go onto GitHub, look up the source code of Spark, look up the source code of Parquet, and see how it works. Okay, so let's have a look at Azure Functions. And what I've done is I've tried to lay out some things that might be very interesting to explain, different ways of using Azure Functions, because Azure Functions are very small composable units of code. You know, a perfect Azure function is something that might contain 5 or 6 lines of code and no more. And you wouldn't want to do anything in a function that Microsoft already provides for you. For example, you may not want to be logging. You know, logging is very important. It's really important to understand what your application is doing, whether or not you've generated exceptions. In an Azure function, all of these capabilities are provided for you. So you don't need to worry about how data is getting to your function, and we'll look at that later. And you also don't need to worry about what's happening inside your function, because Microsoft worries about all of this. So in our case, we'll start off on the left and we'll look at this idea called parametric sweep. Now, if anybody's ever used HPC or high performance computing before, that term parametric sweep should be very, very familiar with you. Now, think about what that means. Parametric means from parameters, and sweep means to sweep through a whole bunch of parameters so that your function can process using the same code but with lots of different inputs. So if you think about from an API perspective, I've given an example, which is how do we get the weather of a city? So there are lots of APIs that give you the weather of the city. If you want to use free APIs online, you can use Dark Sky, which is a very good one. I use Weatherbit. But what I can do with this API is I can say, get me the weather in London, or get me the weather in New York City, or LA, or Beijing, or Mumbai. So in doing this, all I actually need to do is pass the parameter to my function, and the same API client will go and get the weather for that city. So that's what we call parametric sweep. Now, the other aspect of the Azure function is single responsibility. So there's lots of different ways of writing code. And when we tend to write code, we think of writing code in terms of services, and we think of it in terms of objects if we're thinking about object-oriented design, and we think about methods. And so you can see here, each of these in our single responsibility, validate, we may have a validate function or a method. Write Excel, we might have a write Excel method and function. Get weather, send email, check Azure Data Lake, access control list. All of these things may actually be single methods in an application, but when we move to a function, each of these will be single functions, and we don't know where they're going to run. Microsoft will tell us where this is going to run in Azure. It will just go, you write the code, you use the same specification and the interface that we need, and we'll deploy the function somewhere, and it will run somewhere. You don't have to worry about that. We'll worry about that. All you worry about is your 6 lines of code to do your work. So this is what single responsibility means, and you need to think about a function in the same way as you think about writing a method body. Then workflow. You know, very frequently we need to do things in terms of a set of steps. So, you know, here's an example workflow. So we've looked at the single responsibility, but what we might need to do is to check to see who has access to a data lake, right? If they don't, we'll send an email. If they sent a response to an address, we might validate that. So we might run a validate function which will say, you know, has this user replied to our email? Then what we might do is we might write or append row to an Excel document so that an analyst can know that we've sent an email, received it, and they don't have access to our data lake. And then finally, and very prescriptive, it probably doesn't fit in this workflow, but we can run our get weather if you know, with a nice message and say, well, you're in London and the weather is really good. Most times the weather is very good in London today. Most times it's terrible, but it's good today. But you see, this is a set of workflow steps, so we need to see this happen sequentially. Now then there's this idea of a bridge pattern, and we'll look at this more and more as we go through this talk. So when we schedule a function, we can say, I want this function to run, let's say, every 10 minutes. And this we call a schedule trigger, and it has its own clock, and you can tell the clock or the stopwatch to execute this function every 10 minutes or every 20 minutes. Now, what that function could do is it could do some work and then send an Azure Queue message. Azure Queue is a service. And then another function could listen to that queue and say, I've received a queue message, I'm going to write a file to the data lake, to ADLS, Azure Data Lake Service. Then another function could say, well, a file's just been written to the data lake. What I'm going to do is I'm going to send a message on the Event Hub. Then another function could pick that message up from the event hub and say, I'm going to emit a message onto the service bus. And the service bus message probably isn't useful to you if you need to write this to a database. So then the function could write this to a NoSQL database, document database like Cosmos DB. So you can build a bridge pattern in the function so that you can do all of this work, but you can not worry about the inputs and outputs. Again, Microsoft Azure will worry about that. Then you can think about functions in terms of APIs as well. So we might have a get weather API, a get user list API, a send email API, finance metrics API, add user API. And each of these APIs is just written with an HTTP trigger. So if we write a function, which I've said, perfect function, 5 or 6 lines, right? We can build APIs very, very quickly in this way. Now, whilst functions do all of these amazing things, and we can account for them in different ways, like I've said, they also have a lot of incredible features which we can put in place. So we've got things like horizontal scale. So let's say we have 4,000 API requests that we want to run at exactly the same time, right? That's a very, very difficult thing to do on a laptop. Or what will happen is if we try and run this on a single server, there'll be a point where it will just break, right? Because we'll be spinning up too many processes, right? Running and managing 4,000 API clients in separate processes concurrently is a very, very difficult operational exercise. Functions do that for us, right? They'll allow us to have these 4,000 processes, right? Microsoft will be happy to take our money. They want you to have 4,000 of these, not one, but we can do this at the same time, and that's the important thing. Another feature is we don't have to worry about the physical model, where this is going to run, right? Functions are a logical model. So we write a function, this small composable unit of code, and we go from logical and let Microsoft worry about the physical. If we need to have more resources, then it will find more resources to run this function. The other important thing is that we don't just have to write this in one language. We can write functions in different languages. We can write functions in C#, in Python, in JavaScript, in any language that's supported through the web and that Microsoft support, we can write in as a function. Okay, so you don't need to be a C# developer. You don't need to be a Python developer. You can write this in as a Java developer. And there are lots of different ways of deploying functions. We won't cover this in this talk, but if, for example, you prefer building containers, you can host containers in these functions. And then another important aspect is this ability to bind to telemetry. We talked about the fact that functions allow you to log things. So why would I write logging code when a function does it for me? And Microsoft has a service which binds to functions called App Insights, and this will track everything from any exceptions that happen in the function to when the function's entered, when you come out of the function. You can log code within that function, and you can see this externally and run lots of queries on this. And then finally, this ability to basically add users to your function so that you can tie the access to this function to the Azure Active Directory. So you can allow people to authenticate to it and say, if you're not within this user or if you're not within this group, you can't access this function. So some of this today is to try to understand how we bring functions into a modern data platform. So if you think about this, and there's some terms that if you're coming more from the software side and not from the data side, there's some terms that you might learn from here. So one such term is Lambda architecture. So Lambda architecture is an architecture which allows us to bring in data in batch. So we might run a batch import of data every single hour. It allows us to bring in data through streaming, and then it allows us to serve back that data so that we can view it. So if you look at the top line, the top line shows an event hub. An event hub is an event-based pattern, so it allows us to have many messages within the journal of the event hub. And what we can do with those messages is we can queue them and we can take them on at a huge rate. So, you know, the ideal way to use event hubs is to put thousands and thousands of messages on them a second, right? That's when they're at their best. Now you can see that this particular event hub goes in two parts. It's stream processed, so it goes to what's called stream analytics. And stream analytics in this case, you can write queries over a sliding window. So one of the things that I could do is I could say, I want to count the number of events on the event hub every 10 minutes. And then what I'll do is I'll send a message out so that somebody could see on a dashboard how many messages there are over 10 minutes. So that's the sort of thing that I can do. And Stream Analytics is a stream processing capability, and it has many input and output adapters, just like we're going to be looking at how functions do. But in this case, I can say, let's let one of the output adapters be a Power BI dashboard. So then I can use Stream Analytics to just write this value every 10 minutes, count the number of Event Hub messages, and each Event Hub message, let's take an example. Each Event Hub message may be an item within a call center, right, that gets flagged as a high alert, and you want to put this on a dashboard, but you only want to count this every 10 minutes. Okay, so Stream Analytics will send this count back to automatically in real time to the Power BI dashboard. You can also take that data, you can write that to storage, so you can turn this into a file every 10 minutes as well. Now, that's the streaming part of what I call Lambda architecture. There's also a batch part to this. Now, if you look at the bottom layer, you have a bunch of data which is coming in, and that data could be Word documents, PDFs, and we'd call that not unstructured data. Then we have this idea of semi-structured data, which could be JSON or log files or CSVs. And then we have structured data, which could be tables from a relational database. Now, Azure Synapse or Azure Data Factory can pipeline that data. It can put it into storage. It can put it into SQL. But primarily what it would be doing is it would be building up that intermediate data, maybe every hour, maybe every day, and then you would use something, you would orchestrate that through a Synapse pipeline or through SQL or through Apache Spark, Azure Databricks, and you would serve that back as a model, normally what we would call an analytical model or a star schema, and then we could use a tool like Power BI to then read that data. So this would be a very common pattern. It's called the modern Microsoft Cloud Data Warehouse, and you see the bit in the middle is the big data piece. But this is what we mean when we talk about a Lambda architecture: streaming at the top and batch at the bottom. So if any of you are interested or even get quizzed on this in an interview, you know what a Lambda architecture is now. Okay, and just to give you a little bit of further background about how data engineers think about this, you have you have this idea that a data lake now has its own life cycle. So if we look on the left, we can see structured, semi-structured, and unstructured data, which we talked about before. And most of that data in its landed form is useless to us, where it says raw data, because we would need to understand, right, how the shape of every single source of data to be able to make it useful. So this is where automation comes in. This is where we can take a tool like Azure Databricks and say, we actually need to curate this data to make it readable for people. And we could curate the data so that we have an ETL process, extract, transform, and load. We could curate that data so that people could look through this within Databricks themselves and build dashboards, or we could curate that data so that we could then build machine learning and data science models off of this within our data lake. We could then correspondingly read this data through Power BI. We could read it through Azure Synapse. You can see that there's an Azure Data Explorer icon there, which is something out of scope for this, and Azure Machine Learning. But there's lots of different ways that this data could then be used, from data science, from a data analyst point of view, from visualizations. But if we look at how a data platform works inside, what we're actually saying is that when the lake receives this data, when we get this batch data from whether it's API clients, whether it's a SQL database that we want to copy and turn into files, we call this bronze. We call it either bronze or landed data. And this, as I say, it's very, very hard to read because every single data source has different schemas, and these schemas will change over time. Then we have this idea of silver in the middle, and we would now filter that data, we would clean it, we would do something called enriching it. So we might take other data sources and we may combine them. And then lastly, we'll end up at a curated stage, or gold. And what this will do is it will take all of that data and it will put it into a form that's actually useful for people so they can read it. And most times this data, this curated layer, is actually an analytical model. It's actually a model where, like a star schema or a snowflake schema, where people can slice and dice that data in a really organized way. If they're interested in just looking at a subset of the data over time, or a subset of this data as it relates to a particular company, you would basically do it at that layer because it was in a form that's very, very easy to view. Okay, so now we've understood a little bit about data platform. I wanted to introduce you to the idea of building better API clients. Now, one of the things that we tend to do quite a lot as developers is we'll write a lot of code, and we may write this code sequentially. So we may say, in this case, get this weather data, right, I'm going to start by getting the weather data for London. Then I'm going to start by getting the weather data for New York. And you may have a list of things, and what you may want to do is just call this function over and over again to get this data from an API. So in the case of this get weather data, that's a very, very common pattern, right, to build this out sequentially. Now, one of the things that functions give you is the ability to do that parametric sweep, like I said. So we could have one function which contains a list of, let's just say, 30,000 towns and cities, right? But why would we want to wait? Why would we want to call London, then New York, and then LA, and then Paris, and wait until each of this is successful? This will actually mean that we have to wait a lot in terms of time. We probably wouldn't want to do that. So in this case, what we could do is we could take that list in one function, and we could call 30,000 other functions within our list. And what that would do is it would create 30,000 functions, and it would run those independently. We wouldn't have to worry about parallelization code, all of the things that we need to do as developers, like understanding parallel for eaches and these asynchronous patterns. We don't need in a function. The function takes care of that for us. Now, the only problem with this pattern is it's what we call fire and forget. So what happens if London succeeds, LA succeeds, Paris succeeds, but New York fails, and it never writes any files for New York? So you can see the problem here, right? Now, if you're doing that 30,000 times, then statistically, you may end up with failures, especially if the API that you're calling, let's say won't allow you to call it 30,000 times, the API might be throttled, and it might only allow you 20,000 times. So what will happen is 10,000 of these will fail, and you'll only end up with the results for 20,000 cities. It may take you 5 seconds to do this, but if you don't have a recovery strategy, you're going to have missing data. So let's play this through. So we've called our weather data function, we've called it for each of these cities, we've got 30,000 towns and cities that we want to get data from. We then write a file to storage once we've got our weather data. Some of our data is missing because not every single one of these city functions has worked. But every time we get a file written, another function says, right, I've received a file in the data lake. I'm going to do some cleaning on that. And when I've done cleaning on it, I'm going to send a message, a streaming message, so that somebody will have a very, very clean version of the city weather data in real time. Now, if we do this and we don't think about the consequences of failure, where you see the red crosses, right? That's where we'll have missing data. Okay. So if we're running this every 1 or 2 minutes with our function going through 30,000 lists, we can do this. Microsoft happy to do this for us. The problem that we'll have is that if we don't track the failures and understand how to resubmit them, we'll end up with missing data every 5 minutes. So this is a better way of building API clients at scale, but it's not a perfect way. Okay, so let's think about some of the features that functions can give us to try and help fix this problem. So one of the things that is very, very common with a function is this idea of triggers. And when we write a small bit of function code, we can say, I'm calling this a unit of work, so 6 lines of code. We can say that if a file arrives in our blob storage, then we'll automatically call a function. If an event arrives on our event hub, we'll automatically call a function. If a queue message arrives, if a service bus message arrives, if we're using Cosmos DB or SQL, then as soon as a change happens in the database, it will call our function, right? And as a result of that, we can just write out all of this data into storage because functions understand this idea of input output that you can change. And what I've done is I wanted to show you a few scenarios, examples that Microsoft consider here around these triggers. So if a new queue message arrives, we will run our function and write this to another queue. So the queue will be the trigger, and we could have what's called an output binding, and we can bind it to another queue. So we're sent a queue message, we do a bit of work in our function. Let's say that we clean up the text. If there's any invalid characters in the message, we remove those, and we put this message onto a queue. Then we know that we also need to run jobs on a clock. So sometimes we can have a scheduled job, and we call this trigger a timer trigger. So if the timer hits the hour or every 10 minutes, what it will do is it will read data from storage, from blob storage in this case, and it will write that data to Cosmos DB, the NoSQL database I was talking about. Then we have a trigger like the event grid. If any of you have not heard of the event grid, it's a publisher subscriber mechanism in Azure, and it allows you to create topics. So a topic, for example, could be in this case a file that's arrived in blob storage, an image, or a document in Cosmos DB, and the event grid will then publish this topic, and we will be a subscriber to this. Our function will be a subscriber to this topic, and it will send an email using SendGrid. And then similarly, we have an HTTP trigger on this, and then we can take the Microsoft graph to update an Excel spreadsheet. And if you look at the list below, there's all of these things that it can do, right? Functions know about blob storage, they know about Cosmos DB, they know about SQL, they know about the remote distributed framework Dapper, event grids, event hubs. So there are loads of things that you can call a function, and you don't need to write any code for them. This is all declarative, as we'll see. Okay, so I'm going to show a demo. I'm going to have a couple of demos through this, but let's start a new Visual Studio instance. You can also do, if you're not a .NET developer, you can also do exactly the same things using Visual Studio Code. But for now, I'm going to click on Azure Functions here. And let's call this project serverless 360 func. Okay. And I'm going to create that here. And what you'll see is that automatically it asks me what my runtime is. Because I've created this in C#, it will offer me, you know, which .NET framework I want to run this on. It allows me, we talked about triggers, it allows me to say I want a queue trigger. So every time a queue message is sent, I want to invoke this function. We talked about the timer trigger, so I can schedule things. If someone sends me an event hub message, it triggers, or a service bus. Now, this is one of the beautiful things about doing this. And you can see there are even non-Microsoft triggers, RabbitMQ, Kafka. You combine this to a SQL query or a table, and you can also you know, use a bind an output and update this output. So I'm just going to choose something simple for now. I know that one of the things that serverless 360 is good at is monitoring the integration platform. So if we chose Service Bus or Event Hub, this would be good. And we can choose topics, subscriptions. Let's just put this in for here. If I click on Create, everything will automatically be created for me. So let's wait a minute, and we should have our Visual Studio instance. And you can see, right, we have a Service Bus trigger. We have this con string here. So if I look at this connection, you can see that I've got this local settings, and if I want to put the connection string in here so they can find it, I can create this con string and I can put my service bus connection. Okay, and it's literally that simple. Right, so now in a few point and clicks, created a function, and I can change the name of the function. I can call this serverless 360 test. Okay, and it will listen now for this service bus trigger. It will listen on that connection string. It will expect a service bus subscription created called my subscription, and it will publish it on that topic. And I won't need to write any code here to tell me to give me the bytes from this. It will just give me the string value here. Okay, so very, very easy to get kick-started, and I can similarly write other things here. If I wanted to put a return statement and change the type to string, I could just add another one of these declarative things and just put return event hub, and then it will return a string message straight on the event hub if I did this. So this is a very, very powerful thing where you don't need to worry about the source of the data or the target, because the functions framework covers that. Okay, so let's carry on for a bit longer, and I've got another much more informed demo to do. So this is where things get very, very interesting with APIs. So we've talked about functions and what they can do, but functions have a lot of patterns which help us do stuff. So you'll see that we've got this idea of chaining functions together. So we might want to sequentially go, get me the weather data for this city, get me the temperature for this city, and put all this together and then publish this as a list of all of the weather features. Then we talked about one of the issues that we had before. Now, if you remember, the issue was that if we do this fire and forget, functions can scale. So we can have hundreds and hundreds of functions and just go, call me a new function. You might emit an event hub message, let's say, from this kickoff function, and the London function, New York City function, put my mouse pointer over this, and the Beijing function will just be triggered when it receives that event hub message. And then what I said would happen is, if there was a problem and this was being throttled, right, then New York City might actually fail. And you know, the problem that would occur is that all of the other cities we'd have data for, but not New York City, and we wouldn't know about it until we listed this. So I said that there's a better way of doing this, and it's a pattern that Microsoft have called fan out, fan in, which I'm going to show you an example of. Then there's another function pattern. There's about 6 or 7 of these. I've only listed 3 because they're 3 that I use regularly, especially for APIs, called a monitor pattern. And what a monitor pattern will do is it will get, I can say, get some weather data, right? And I can run this to a function to just say, is the sky clear? If it's clear, send a notification message on the notification hub or to Twilio or another output binding, and then that will send me an SMS. So one of the things that you'll find, the more you use API clients and you want to use these very, very amazing data platform patterns that I've been talking about, is that you need to mix API data, which we call enrichment, with actual data, which might come from SQL, it might come from files, and you need to put these together. So in this case, let's go from left to right again. This is a data orchestration pattern, and the factory in the middle, that's the thing that orchestrates everything, and it's called Azure Data Factory. And what it starts orchestrating here is it goes off to SQL, and because we've got a list of 30,000 towns or cities that we want to get weather data for, we might want to know something extra about these cities, like population. We might want to know some fun facts about each city as well. And these might be stored in a SQL database. And so we want to go and get those city attributes, and we want to get them, let's say, every hour. And on the hour, we also want to use that list of 30,000 cities to get the weather. But one of the things that's important to us is that we see all this data together as a big wide table. So we need to get those 2 sources. Data Factory says get those 2 sources are the same. All of the weather data using functions, get me the 30,000 cities, and let's read the cities table to get all of the fun facts. Then every hour we would write this. Data Factory would say, I'm going to write this to a transient location in storage. And then you'd have a big data part to this, like Azure Databricks, and it would join these together and it would put it back into a data lake or to storage, and it would put it in an hourly folder. And once it's done that, we might have another function at the end which will be triggered because we've written a file, and it will notify someone that a file has landed, so they can quality check it, they can do whatever, they can load it into Power BI, lots of different things they can do at that stage. But the other thing that we could do, which is interesting, is let's say that we've got a lot of IoT data coming in, and the IoT data is coming from buildings, and we're using a streaming event hub here, and all of this telemetry is coming from sensor data. Now, if we're getting weather data every hour, right, what we might be able to do is to say, I'm going to overwrite some reference data in our stream processing engine every hour to tell us what the temperature is in the city. Because one of the things that I might want to do is look at the sensor data and say, well, why is it that the temperature is in this, well, why is it that the temperature in the city is, let's just say, 38 degrees centigrade, and yet someone doesn't have their air conditioning on, they have their heating on. And so what we can do then is use what we've collected from the functions as reference data with the streaming data from the sensors and say, this is an anomaly. We have to think about alerting someone. Okay, so you can see that there's some really incredible patterns that we can put together when we start thinking about how we can use API clients with Azure Functions. And so when we think about this idea of fan out, fan in, we need to differentiate, like Azure does, between logical and physical parts of the function. Now, all you really need to think about is the logical parts. Now, you see here that we've got a function which has a scheduled trigger. It runs every 5 minutes, and it goes and gets the weather for London, New York City, Beijing, and it might do this for another 400 cities. Now, in fan out, fan in, this pattern we talked about, this will actually fix the problem of fire and forget, of just running a function and asynchronously not knowing whether it succeeded or failed. If it's throttled because the API is having too many, the API has too many requests, it will generate an HTTP 429 response. That's standard for throttling. Now, we either want all of our cities or none of them. Okay, so let's be clear. We've got 400 cities here, we're getting the data, and if London fails, we want to wait until London succeeds. So what the function will do is it will create a back-off strategy, and it will say, if this fails, let's try a second later. You know, we won't try right now, we'll try in a second. And then we get all of the functions together, and we can list everything. Now, if we need to expand to 400 cities, we might need more physical infrastructure. So you can see these worlds, these spheres on the right, they're called app services. And the functions are actually hosted on these app services in Azure, and we can add more to them. So if we need to go from 3 functions to 403 functions, right, it needs more compute, it needs more processing capability. So what we will end up doing is just adding more infrastructure, and we can scale this up. We can even tell Azure to do this for us automatically, and when we've run these functions, we want to bring them back down again so that we're not paying for all this infrastructure. So that's the benefit of fan out, fan in, right? It makes everything successful, number one, and at the same time, it allows us to just pay for the actual infrastructure that we need to complete our function API call at scale. All right, so let's look at fan out functions. And so I've written, this is something that I use for teaching, and what I wanted to do is put 2 patterns together, and I'll explain to you what they're doing here. This is called a durable function, and function 1, this file here, uses one of the techniques that we talked about called function chaining. And what function chaining does is it calls these sequentially. So you can see that I've got a method here, my function called getCityWeather, and in getCityWeather, I pass in as a parameter this number, and this number is an ID which tells us what the city is. So the actual city here, in this case, is, I can't actually remember, I think these are US cities, but it will pass it in here, it will call the WeatherBit API, and then because the WeatherBit API sends us JSON, it will get the city name, it will get the description of the city, and then it will give us a string to say the weather in this city is cloudy, or the weather in this city is sunny. Okay, so we've got an orchestrator, you can see at the top, which where we can give it a list of cities, and it will call these one after another, and it will make sure that each one succeeds, right? And if they fail for whatever reason, it will also tell us why they failed. And then we've got this, which is the weather start function, and if we want to start this, it just has an HTTP endpoint to start. Okay. So I'm going to run that before we look at, this is function chaining. I'm going to run that before we look at this fan out, fan in pattern. Okay, and you'll get this pop-up box here. Okay, now you can see. So in our function chaining, I've got this localhost 7071 API weather start function. So I'm going to copy that, and if I enter that into my browser, it will start this. Okay, so let's move across to here, and I'm going to enter that into our browser. And here we go. We've seen a weather start function. Okay, I'm not sure. I've got a breakpoint in here as well. So we can stop, and you can see it's called the API. It says weather in the city Raleigh is overcast cloud. All right, so let's run that again, because we've done that for 3 cities. And it's broken again. Weather in city Thomasville is overcast clouds. Oh wow, weather is pretty bad in these places. Okay, and lastly, weather in city Williamstown is broken clouds. Okay, so let's continue through. And we've collected all of our data, but you can see it didn't come in parallel, they came in one by one. And sometimes we would normally use this function chaining pattern to do this one by one sequentially when we wanted a set of steps to work in a workflow. So this is I'm doing a different example here. Now, our orchestrator gives us this URL, so it's telling us where we can query the status of this. And if I query the status here, there we go. So you can see that our orchestrator gives us some nice JSON, and it says, here's your results. Okay, weather in the city, Raleigh is overcast, in Williamstown is broken clouds. Okay, so now we've managed to put that together sequentially. So if we look finally at this, and this will be my final example, I've got a list of cities, but this time we're doing fan in, fan out. And this fan in, fan out, you can see here, it will just queue these as tasks, and it will just wait until these tasks finish. Okay, and then I can do things like put cancellation tokens, or time this out, or query and find out if any of the tasks have failed. So this is very, very different from the chaining. Right, I'm doing all of these in parallel, I'm doing them concurrently. Okay, and this is where the power of fan out, fan in occurs. Okay, so let us take the name of this function, which is weather orchestration fan out, fan in, FOFI. Let's change the name of this to API and fan out, fan in. And there we go. So we've got another status. I will double check. Nope, I don't have any breakpoints there. And if we get the status endpoint URL, okay, same thing. We've got the results. We couldn't see because I didn't show you, and I haven't actually measured the time period that it took. Maybe somebody picked this up, but what you probably should have seen if we'd done this properly, you can see that there's literally milliseconds difference, like 4 milliseconds that difference, right, where this has so quickly done all of these 3 requests together. So it's faster than the chained function. So really, really impressive how powerful this can be very quickly. Okay. So we'll move away from our example and we'll go back to Just a last slide to understand some of the use cases that we can do before wrapping up. So a couple of different things we can look at. We'll look at integration and sync patterns, and a very common thing is the idea of security. So we can get security data, we can write this data to a log, and we can query this data with Custo. And a lot of people do that to supplement platform issues with security. So we might use APIs of different vendors to do this. Now, my final very common pattern, which you can use here in terms of a function bridge, is when you have a cross-cloud data transfer pattern. So being able to use an S3 bucket to get data, write it to Azure storage, and then read it back using a function. So I wanted to show you that aside from API clients, there's so much more that you can do in terms of an integration platform with Azure Functions. And I will hand off now to Serverless 360.
Richard. So thanks for the presentation. It was very insightful. So as you can, so all the audience, as you can see in the screen, which says serverless 360. So you can build, as Richard said, you can build applications, or you can, use your function apps in building an applications. But what happens after the development phase? You have to manage and maintain those applications, right? So serverless 360 will be the right place to do it, because with serverless 360, you can logically group all of these different integration services and have them as an application visualization. So you can visualize how your integration services work together as an application. You can spotlight failures within this, and you can even debug directly from Serverless 360 portal. So Serverless 360 will act as a single place for your Azure support or business users to take care of all the failures that they deal with in your day-to-day activities. So if you want to get an hands-on experience of the tool, we also provide 15 days of free trial. So you can just leverage the 15 days of free trial, and the free trial link is dropped in the chat, and whoever wants it, they can have a quick look into it. And these are few outcomes that we derive from serverless 360. So you can as I said, you can organize all of your Azure resources in a one place, which means you can pull in resources across multiple subscriptions, even across multiple tenants, and have a better visualization. And you can unlock observability with distributed tracing. So one common challenge that every organization would face is having an end-to-end visualization of their message flow. So you can get this visualization with ease using the business activity monitoring module. And obviously this is in cloud era, right? And everyone is migrating towards the cloud, and we obviously need to have a proper governance on what we are doing in the cloud. So for that, we can use the Azure Documenter, which automatically generates document for all the subscriptions that your organization has. And especially for developers who love dealing with or playing around with data related services, the go-to option will be Cerebrata. It's a cross-platform application with which you can manage all of the Azure data related services from a single place. Say you get access to storage accounts, service bus, Cosmos DB, SQL databases. So all of these different services can be managed within a single platform. And free trial for the Cerebrata is also available in the chat. So if you want, you can just have a look into it. And hope you all would be aware of the Integrate 2020 conference happening in London. So it's an Integrate is the biggest conference organized by Microsoft. It's for the Azure integration space. So it's a 3-day event, starts from June 13th and ends on June 15th. So in this Integrate conference, you can find all Microsoft MVPs. You can find Richard there as well. So he will be presenting, I guess. So if you want to have a look, or if you want to get the latest trends and releases in the Microsoft integration space, the go-to place will be the Integrate 2022 conference. Yeah. So if you have any feedbacks or if you have any questions, you can drop it in the chat window, or you can even personally contact Richard.
Yeah, more than happy to have any questions or queries directed to me. Okay, I just want to thank you for inviting me to speak, and please feel free to send any questions to me on Twitter at Azure Coder, or LinkedIn. You can find me as Richard Elasticloud.
Perfect, sure, Richard. So I once again thank you for this wonderful session. It was very informative. Thank you, Richard.
Thank you.
Thank you, everyone. Have a good day.
Coveted.co